Oh, didn't see you there. We were just over here. I was just over talking to the door and didn't see you. How, everybody? I guess we're going to do KidzCode this morning. How you doing, Campbell?
I'm doing good. You?
Yeah? I'm okay. I'm okay. A little bit tired. We'll see how the day goes today. You know, it's what, New Year's day after, right? Isn't that what it is
it's
today?
The day after New Year's. Yeah.
Day after New Year's. I think that's correct. Yeah. So, anyway, that's kind of how we are. You want to, anything you want to say or talk about before we start going to what happened last time?
Oh, so last time.
You want to go right into it?
Yeah.
Here we go.
Sure.
What happened last time?
So last time we started graphing y equals mx plus b in Unity. So we created a graph with an x-axis and a y-axis. And then we put those perpendicular to each other, and we parented them to the graph, which is a game object.
We parented them to the graph.
Which is a
game object, yeah. Okay, cool.
Which is a game object with the transform and the graphinator script. And if we open the graphinator script up, okay, we wrote some code. We created a So basically what the code does is it instantiates a bunch of spheres that create basically a line.
Right, you can kind of visually connect the dots.
Yeah.
And the distance between the spheres on the x-axis is given by a property we have up at the top called step. Right there. We're defaulting it to 1 here, but I think in Unity we're changing it to 0.1. And that, if I just switch to my machine, we're talking about the distance between the dots on the x-axis. So we're talking about this distance from about the center of this one to the center of that one. That's the step on the x-axis, right? The problem is, or I guess one way of thinking of this, I don't know if you want to call this a problem or not, but one of the side effects of this, let me just select all of these here for a second.
Can you turn down the music?
You bet. I'm sorry.
Just a bit.
How about that right there?
Yeah, that's much better.
And folks out there, let me know if how the music is for you out there as well. Yeah, thanks, Campbell. Definitely. So let me just group these like this. Do I have one more inside here? It looks like I don't have one across the middle. Okay, so anyway, let me grab these. I'm going to group them. We're going to rotate them. The problem is that when we get to like this kind of an angle, a really steep angle, this step doesn't change. So what really happens is now the line starts to look like this. Like that. Does that make sense? So they seem farther apart. Does that make sense, Campbell, what I'm showing, what I'm talking about?
Yeah, they do.
Okay. And then the other problem related to that is if we come, as we come down here, they start to look, I think they start to look closer together is what I think they start to look, is what happens, yeah. So that's kind of what's coming down here. So like right now, if we said that was the distance between the two, now what'll happen is these will be like closer like this. See that? What's happening? Yeah. They're like that far apart. Anyway, I just want to say how happy I am that nobody's going to interrupt the show this morning with Pudding. Oh my gosh, Pudding! Come on, Pudding! Come on! What are you doing, Pudding?
Messing up our keyboards again.
Wait, what'd you say, Campbell?
Messing up our keyboards again.
I got Pudding in my keyboard. What am I supposed to do? Happy 2001
No, my space bar doesn't work.
What'd you say? What doesn't work?
My space bar.
Yeah, my escape key is putting up Pudding whenever I push on it. Come on, Pudding. So they get closer together right down here. So the distance, apparent distance between these changes, I'm just going to undo all this here. But that's kind of what's going on. That's one of the things that's happening there. But that's what step is. And then we have two other properties over there. Let's switch back to your machine.
Our two other properties are, well, the point prototype, which is...
Well, hold on. I wanted to talk about, if you don't mind, just go back. I just want to, while we're talking about step, I want to talk about start X and end X. That tells us where we're going to start looking at X and ending at X.
Yes. So basically that says where the first point is going to be and where the last point is going to be.
That we're going to visualize and graph.
Yes.
So we're basically going from -50 to 50.
Sorry,
but we could change that from -100 to 100, or from 5 to 5, or from from -5 to 5, or from -1 to 1.
Yeah, it could be anything.
Okay. So that's what we did. Do you want to show it running? We also have, we've got some shortcuts in the code that respond to, we've got code that responds to keyboard shortcuts.
Yes.
And do you want to show that real quickly?
Yeah. Wait, oops. Visual Studio. Where is it?
What it says, -255 to 255. Yeah, we could do that too.
Oh yeah, okay, right here. So if get key down, if we're holding down if the up arrow is down, then we change B.
If the shift key is also down.
Yeah, blah. If the shift key is also down and the control key and the up arrow is down,
right,
then it's then B is equal to B plus get step. If shift key isn't down as well, then
M is equal
to M.
Right. Look also at what happens in get step. Do you remember this?
If control key is down, yes.
It's a big step, and if it's not, it's a small step.
Yeah.
So that's kind of what we were playing with. All right, you want to learn a little bit of math for a second?
Sure.
Really? Okay. Let's switch back over here. We're going to go over here. We're going to talk about something called polynomial equations. Polynomial equations. I have to tell you, when I remember learning this, Campbell, when I was, I don't know, your age or probably older. And I remember when I learned this, I was like, what are all these big words they're throwing at me? Right? Pudding, by the way, is throwing out x squared plus x plus 1. Yeah, when he had hair. This is when I had hair. And so I'll just write what Pudding wrote down right there. So he was writing x squared, and this is how we're doing squared in
I know.
In code, plus x plus 1.
And that's also how you do squared in, like, if you're anything but a calculator.
Yeah, we just have text.
If you're writing down.
I can actually take this and I can superscript it by clicking, I think, here and saying superscript like this.
Superscript.
Like that. Now also, and then Puddings also says, and then equals 0. And the reason I think he's saying that is because often you see this. You see the, hold on, I need a small x. There we go. X squared plus x plus 1 is equal to 0, as an example. And the reason when it's equal to 0, well, let's talk about that for a second. Let's first go into here and say y is equal to this, like that. Yeah. Okay, fine. Fine. Pudding is raising a really good point. And simultaneously reminding me that I don't have featured chat up there, and I need to do that because I want to highlight what, so everybody can see what Pudding is saying out here. Give me a second to bring that up. About one more click, I think, away. And scrolling down, and boom. Do we see it? There it is. Because it's not a polynomial equation if it doesn't have an equal sign. Because basic math is the only field I can beat Murky at, apparently. Well, yeah, that might be true. That might be true. Or actually, it's probably true. There's loads of things you can beat me at. But you know what? It's okay because I'm pretty comfortable being an amateur at math.
I feel like basic math, you don't really have to know because you have calculators.
Because you have calculators, says Campbell. Well, okay. This is also, a lot of people would consider this basic math. So I'm also going to say, though, I'm going to also argue Pudding. Pudding says true. I'm going to argue that I've got an equation if I got the equal sign right here, and I've got y on this side. I'm going to get rid of the dot right here so we've got a little bit of clarity. So there's like an example, like this. Okay. Here's but the important thing here is well, we're setting it to 0. We're essentially, what are we setting to 0 here, Campbell? What variable are we setting to 0? If this one is similar to this one, we're setting y to 0. And when y is 0, what are we talking about? What are we looking at in terms of points? Where are they on the graph? If we were going to visualize that, where would those points be if y was 0?
Center.
Somewhere, not centered.
Sorry.
But, well, centered vertically. Somewhere on the x-axis. Right? Right. Okay. So this is an example of polynomial equations. You're trying to do functions, not equations. That's kind of where we're at putting. But it is an equation. But here, setting y to 0. This is what we're really talking about is like finding something called finding the roots. In other words, we're asking, where does the graph cross the x-axis? Finding the roots. In other words, where does the graph, right, the line we're creating, cross the x-axis? In other words, when y equals 0. Okay? It's kind of weird because the polynomial represents something, you know, big and beautiful that can be curving and all over the place, or a straight line. But this question of where does it cross the x-axis seems to be a focus of mathematical training and study. So you'll see that. What we're going to do today is we're not going to really worry about the roots because we're going to draw it. Okay, does that make sense? Campbell? We're not going to look, we don't care just where it crosses it. Did I just talk too fast? You slow me down and stop me.
No, you didn't.
Yeah.
But I remember when I first learned that you can switch whatever, like the equation, it doesn't matter which thing is on either side of the equal sign. True. You can flip them around. I first learned that and I was like, ooh, because I was so used to it being something plus something else equals this. So it would be the long part and then the short part.
Yeah.
But then when I think you were the first one you told me that you can do it either way.
Yeah.
You did the short part and then the long part.
Yeah.
And I was like,
if I'm understanding you correctly, I agree with that. So the idea is kind of like, it's kind of like this. If I have something here like this and it's balancing, and over here I have some other things stacked up, and we're balanced like this. Does that make sense what I'm saying?
yes.
Hold on, let me just move this up just a little bit, like that. So if we're balanced, then let me do one more thing. I'm going to copy all of this, shrink it down, group it, shrink it. If we're balanced, that means that we can switch the locations of these.
Bloop. Yeah.
And it still will be balanced. That's essentially what an equation is telling us. Let me get all those selected. Let's move all those over to this side. And then let's grab the other one and move it to the other side. Oops, that was the wrong one. Bring it over here. Right? In other words, it'll still be balanced. That's what the equal sign is telling us.
Yeah.
Related to this, okay, this is kind of a, advanced math here, but this is in here. Let's draw an equal sign underneath it here. I'm actually going to hand draw the equal sign like this, like that. Group those, drag it over, right? Let's duplicate this slide, get to the next one. Now let's say we didn't quite have this here. I feel like I hear a dog whining outside our door. And let's say instead it looked like this. Oops, I didn't mean to duplicate it. It was not balanced. And so now what do we have? We have something that's like less than or equal.
Yeah.
I'm going to build a less than or equal sign here too. Let me ungroup this for a second, because I like the big kind of look here. Maybe something like that. So take both of those, group those, kind of do this, or maybe just call it less than. We're just going to call it less than.
Yeah, it is less than.
Okay, yeah. So we're going to say this one is, and actually it's the other way around. Let me do one more thing, because it's heavier, right? Yeah. Let me do this, and do that, I think. Wait, is that what I want to do? I want to group them. do one more because I want to get this and this break to the fragmented. Oh, it's that one right there. I'm sorry. Okay.
Jalisco 7, where are you?
So now I can flip this.
Oh, not around. Here, I am.
Now, here's the thing. So if I've got this, where this side over here is greater than that, and maybe to illustrate it, I might do something like this, where we take one off, right? Does that make sense to you, what I'm doing, Campbell, in the visual? Right? Oh, and I just realized you're blocking a little bit.
Yeah.
Let's do that. Polynomial pudding. Yeah. So we have this, and we know this is true, right? The right side. I'm sorry, my OCD is coming in here, Campbell, and saying, you know what?
Yep, it's not.
I want this to look more like that is what I want it to do. Okay, there, now I'm happier. So if my OCD comes in and says this is true, right?
Yeah.
I'm gonna select all of that, group it, copy it over here. Watch what happens when I mirror this.
Whoa.
It's still true.
Yeah.
When I flip it left or right like this, right? But look what happened to the sign. So if I have something that says A is less than B, for example, like here, A is less than B. Here, whoops, I got to do it the other way around. Let's say A is greater than B. Like that. And I flip it. I mirror it. I also have to mirror the sign. Like this. And if I'm going to put these on the opposite sides of each other. Does that make sense?
Yes.
By the way, you're totally off camera. You're totally...
Yeah, I'm trying not to block it, though.
Oh, I see. Well, let me just tell me that, and I'll zoom it out like that.
Okay.
Then you get back in camera, and then I'll do this. Yeah. So that's kind of what's going on there. Now, with the equals, it's a little trickier because you have to remove, if it's less than or equal, then you have to remove it when the equal when you flip it. Or if it didn't have it, if it's less than and you flip it, you got to add an equals. It's a little bit, you know, whatever. That's a little extra piece right there. That's just like, you know, that's just some like math flipping techniques. I'm going to throw that out right there. We'll just say math flipping techniques. Flipping meaning we're moving on to the other side of the equation. But normally we're dealing with an equal sign. So an equal sign, we don't have to do this kind of stuff. Okay? All right, so we've got this. We can flip on either side. I'm going to go ahead and add this as well to our math flipping techniques page. Let's take all of that, move it closer, take all of that, group it, shrink it, put the other one in here as well. All right, do you understand both of these pictures, Campbell?
Yes.
You get a sense of these? Okay, good. So those are my flipping techniques. Back to polynomial equations. Let's look at the big picture. Polynomial, big picture. And it kind of looks like this. This might be a little mind-blowing to you, but we're going to do it anyway. And just, I want you to relax during this, Campbell. If it's mind-blowing, don't worry, because we don't have to, it's not anything you have to fully understand. What I really want you to understand is the big picture. That's what I'm going for here on this, okay? Which is, doesn't require you to understand the mind-blowing part. If that makes sense to you, what I'm saying? All right, this is going to be n right here. So we start up like this. It's a sub n, which means that can be any number.
Yes.
That's a unique number, okay? Looks like I got a whole bunch of spell checking going on here. Can I turn off spell checking? Spelling, turn it off. Where is my way to turn it off? That's not quite what I want in here. Language. Is that going to help me? Yeah. Set proofing language. Do not spell check. Don't check spelling. All right, cool. So it goes here. Then it goes to plus. And then here we have an n minus 1 raised to the n minus 1 power. And this is just, all this is like an indexer. It's not n minus 1. Yeah, I think that's fair. That's totally fair. It's an indexer. All right, so it looks like that. Then it goes to plus again. And this is going to be like n minus 2. And there's this pattern that's kind of driving down here. Like here's what we're doing. One other thing I think I want to do to make this a little more helpful, easier to understand, is I want to color code these. So I'm going to make the number I multiply by be purple right here. So that's purple, and this is purple. So these just, all this n, a to sub n minus 2, all it's saying is that's a number, like 3 or 4 or something. It's going to be something. What's it saying? There's a number before x. X is going to be the same variable every time. And I'm going to make the power, I'm going to give it a different color too. I'll make it this blue. Okay? Like this. And we finally work our way all the way down to something like a sub 2 times x squared, or maybe even better, to give this a bigger picture thing, we'll make it a sub 3. So you can kind of see the pattern here, what's going on here. That plus...
Wait, why?
I'll show you, we're getting here. Plus that, okay, see it? Plus this, whoops, a to the sub 1 right there, plus, and then we're getting to here. Whoops, shoot, I deleted that before I got it. Putting sub n is what putting's saying. All right, and we get to that, and that's equal to y. Okay, so the big polynomial pictures means n can be anything. If you want to make it be 100, that means I've got x to the 100th with my multiplier in front of it, whatever that is, a sub 100, which is going to be maybe equal to 4, plus a sub 99 times x to the 99th power. See what I'm saying? Plus a sub 98 times x to the 98th power, right? Notice that a sub 98 could be 0, and it still counts as a polynomial. So what a polynomial big picture is, Campbell, it's basically the ability to talk about x and y. We're talking about a two-dimensional relationship between x and y, and x is something that we can multiply by a number like 1, 2, 3, 4, 5, and x has a power like 0, 1, 2, 3, all the way up. Oh, and there's a dot, dot, dot here too, I forgot. This just continues, the pattern continues. Does that make sense? Mm-hmm. All the way up to 98, 99, 100, and we finally got the equation. It's a little mind-blowing, I would argue. The first time I saw this, I was like, what the what? Why do you even, I don't even, what? Like that.
Wait, no, it's not. What if n is negative? Then we'll never get to...
Yeah, n is not negative in terms of this definition of this. What you're looking at is kind of not really math, but a way of describing math. Does that make sense, what I'm saying?
Yeah.
It's a way for me to just show you this thing can get big. So as some examples in here, I can say 4x to the 99th power, like this. Hold on a second. Let me superscript this. Like that. Okay. So I've got 4x to the 99th power plus, I don't want that one superscript. Like that. Plus, I might have plus 5 equals y. And that is a polynomial equation. Because what's happening for all of these, and in fact, let me syntax highlight this so it's using the exact same coloring we did before. That's going to be this one's going to be blue because it's the power. And in fairness, this is going to be x to the 0 power right here. So if I superscript that as well, change it to blue, change that to the purple. Yeah, so now you think you're starting to see it. Basically, all of this is saying, hey, you know what? Polynomials can get big if we want them to. That's all it's saying. So that's an example polynomial right down there, right? Example. Let me show you another example polynomial that you've probably seen before. Looks like this. Y equals mx plus b. Here, you've got x to what power? Do you know what power x is here?
To 0.
Not to 0. X to the 0 is equal to 1. One more guess. Your life depends on getting this right, by the way. I'm going to have to enforce that if you get it wrong. X to what power is equal to x? It's also okay not to know. I'm just kidding about that.
Oh, x to the power of 1.
There you go. It's x to the power of 1.
Well, then why is 5x to the power of 0?
Because
oh, right, because we're not registering x, yeah.
5 times, I'm trying to show you how it fits into this right here. You see what's happening? This is the same as, I could take this off here and it'd be the same. Does that make sense what I'm doing? Okay, but I'm showing you the pattern, right? It's just the numbers are going down. The part of this that's real math are the exponents here. The part that's kind of not real math or just a language describing it are the a sub 2, a sub 3, a sub, you know, all these are just meaning it's a different number is all they're saying. They're unrelated numbers. So here, in y equals mx plus b, right, the m is equal to a sub 1.
Yeah.
See it? Right there, see that match? And b is equal to this, a sub 0. Do you see that connection? Right here?
Yes.
Because that's the same as, boom, it's the same as this, right? B times x. Okay, you got it? We've seen this, that's a polynomial. The one I want to do, one other thing, there's just one other new word I want to show you to teach you. And that word is degree. And it's kind of, degree is a similarity to dimension. Remember we talked about dimensions?
Yep.
What different dimensions are? The degree, let me make this in red, right, like that. The degree, let me get you an arrow down here. It's Litany says, mind explodes. Wow, this is deep. I'm sorry, we're going to get out of the deep real quick. Sorry, Litany. You're right. Sometimes I have that, you know, I don't know when to stop. But the degree, let me make this red too.
It's what n is.
It's kind of what n is. It is, yeah, no, actually you're right. It is exactly n. You're right. It is that. So what I'm going to do is I'm going to come in here. I just want to make that a little smaller. Come in here, do this. There's my degree. And guess what my degree is up here? It's that.
N.
It's the highest number. Okay, so my degree is the biggest number I've got. Okay, and there's my degree right there. I guess I don't know what I got to do here. I got to put it down a bit so we can show it. Or maybe throw it out here. And we'll put this over here. So my degree is what's the highest number. So in this polynomial equation, we could say that the degree is 99. In this one, we'd say it's n. And in this one, we'd say it's 1.
Yeah,
now,
but the thing is with the top equation, it could be in any order, so it doesn't always have to be the first n, right? It can be...
Yes. Well, it's not, yeah, it's not the first n, it's the highest n. All right, that was some awesome math. That's intense, isn't it? It's crazy. No, it's mind-blowing and crazy. And the thing is when you see this, I just want you to be like, hey, you know what? You don't really have to figure that out. It's just a way of saying, I got a bunch of different numbers. And they're not related. They're different. Okay, does that make sense? Yeah. It's just kind of like, it's like, hey, don't worry about it. That's all that's saying to you right there. Now, we've seen this. This results in what kind of... We're doing it again? It's Litany. Come on. All right. Somehow I deleted that. All right. We saw with this, it was a line, right? Can we demonstrate that? Can we run on your program? Show us running the code. Campbell's really lucky he has someone to teach him this stuff. Says smash.
Dad, is my mouse on your machine?
I don't think so. No? I see it on your machine, actually.
But
I don't think it came to mine. Did it? Okay. Oh, maybe it did.
It seemed like it did.
Oh, maybe it did. We can work on that. You can shut that up next time. And can you close down the Skype window right there? All right, so here we've got y is equal to 0x plus 1. So what do you want to change? Change some things and show what happens to the line. So here's the line. Yeah, goes down, there it is at 0. We can rotate it. So we see as we make the changes to the multiplier times x, it changes the steepness of the line. And what we're going to do today is we're going to increase the degree by 1. So we're going to add we're going to create something that says y is equal to something x squared plus something times x plus 1. How do you feel about that, Campbell?
Good.
Good. All right. I've been thinking a little bit about this. And what I think I want to do Okay, what I think I want to do, Campbell, so because this before was kind of working with the M's and the B's, we're going to now change that to like A, B, and C. Does that make sense? We're going to have A times x squared plus B times x. Giving people a little bit too much control this morning, it feels like, Campbell. I think people don't want to see math. They just want to see us dance. We could just do a dancing show. By the way, I really like syntax highlighted math. I find it way easier to understand.
Much easier to understand.
Yeah, that's what I'm talking about. I really, really like it. Oh, which means, by the way, down here, I should come down here and make this purple as well. And it also shows the relationship because, you know, it's easy to teach linear equations. Look who's here. Look out.
Ooh.
Who's that guy? Cody Grill, I'm sorry, buddy. I think you don't have the ability to make me talk on this show. I haven't figured that part out yet. I haven't spent any time to work on that. But if I give me a second, I can probably push that up there. And let's see what I can do here. Here we go. I can just paste in what you did, if I could actually get it in the clipboard. Forgot I was lurking in the shadows. No worries. Yeah, I know. I forget that sometimes too. All right, let's see. Does that work? Sound like that did. Yeah, I've just got to bring it up. I knew I shouldn't give them all these commands. Yeah, so I like syntax highlighted math better.
It's so much easier to because then you don't have to imagine which pieces are related.
Right.
You automatically know.
Right. I also think it's important. I think it's good and important to understand the big picture when you're learning a small piece. Right? So you've learned y equals mx plus b, and generally people learn it without understanding the big picture, right? And you think you're looking at one thing, and then sometimes you'll get to another class and they'll say, okay, let's talk about polynomials. But they often won't come back and say, oh, you remember that y equals mx plus b? It was a polynomial.
It was?
Right? Yeah. Genesis says, all those party modes, I wish I could go to code. Couldn't you had that sound alert with lurking? Hold on a second. Let me see if I can make Campbell talk now. How do I make Campbell talk? It's a different... What is it? Oh, yeah, it's a different piece right there. It's a different command. Yeah, I know, guys. We'll do this one, and we'll give Campbell a thought bubble here. Did that work? Did it work? It didn't work? No. That one works. Hold on. Maybe I just got the wrong thing in here. Oh, yeah. It's... No. It turns out Genesco 7 was right. Let's get that fixed. All right, there we go. All right, all those party modes, I wish I could go to code. Is that what you wish, Campbell? Well, fine, we're gonna go write some code. Let's do that. All I wanna do is write code. So, but here's the idea that I had, Campbell. Instead of making Control-Shift kind of modify these, because we're now getting to a point where what's this going to look like? Let me put one more example up here. Just one more example, because really specifically, this is kind of what we're going to. Come on, give me something out here. example. Another example like this. I'm going to grab this. Come over here. In fact, let's go to our own page. We're going to create a new page here called binomial equations.
Like a polynomial, but
Yeah.
it's a binomial.
Yeah. Or actually, maybe, yeah, I think that's, I'm using the correct term. A binomial equation has a degree of 2.
Always?
Is that right? Yeah, pretty sure it does. And so it'll be like, this will be like an A right here, and this will be a B right here, and that'll be raised to the 1 power, and then plus C is generally what happens right here. And this is kind of what it looks like. Generally the Y is on the other side. So it's like Y equals, come on, Y equals, please just help me. And let's change this to black. So it looks like that, which can also be rewritten as that. Does it make sense? And well, actually I can get rid of that 1 too. The simplified version of this, see it? It's that. Okay? Binomial means you have 2 variables. What are you looking for is quadratic? All right, fine. We'll say quadratic. I'll take it. And there is proof. So there's the quadratic equations. All right? Those are quadratic equations right there. I'll take it. That was the other word I was considering throwing out. They're called quadratic. I don't know why, because it's kind of like you've only got 2 dimensions that they're working in.
Yeah, quadratic seems more like 4.
I think they're trinomials as well. I thought it was the degree. I thought binomial was the degree and trinomial was the degree, but I could be wrong. At any rate, this is what we're going to do today. And notice I've got now, instead of M and the B, I've now got A, B, and C. See it?
Yes.
Now, let me tell you what I would do if I was teaching this. If Mark was teaching...
Uh-oh. It's going to be a bumpy ride.
It's going to be a bumpy ride? Did you really just say that? Okay, fine. Let me show you what I would do differently. I would make this A, that B, and this C. That's what I would do. And I would probably, you know, I'd probably keep the exponents here just to remind people what's going on here. Like that.
Yes.
That's what I would do. Now, why would I do that? Because now, if I want to go to the third degree, it would be, this would be a D, and that would be a 3. Do you see what I'm doing here? Hold on a second. I got to get a plus in here.
Oh, yeah, whereas otherwise it would have been.
Yeah. Binomial means we have 2 dummy variables x and y, and you're working with a monomial, just 1 variable x. Okay. All right. I'm gonna go with that. So this would be dx cubed. This is, I think, known as a cubic equation, if I'm correct on this. But you see what's cool about this? The a always stays with the x to the 0 power. The b will always be with this. So if you learn, that also means, so we've got a quadratic equation here. If you've got to go to a linear equation, which means we're drawing a line, it looks like that. Do you see what I'm talking about, Campbell?
Yeah.
We're talking about, you know, making them all look the same. So I think it's easier to understand. That's kind of what I'm arguing, is that I think that the way it's taught and the conventions that used are make it harder to understand. This is a linear equation. Right there. That's called a linear. It's called a quadratic. And they're just names, right? We can call them anything, like a zebra equation, whatever. But I'm just, and you don't have to remember any of these right now. And this one over here is called, I think, a cubic equation. I think, but I could be wrong. I think that's what that's called. I'm going to put a little question mark there, meaning I think that's what we call that. Okay?
Yeah.
All right, the cool thing about doing it this way, if Mark was teaching, is that this stays consistent all the time, right? Whenever you're multiplying by this last piece right here, right, it is always the same. And again, we can simplify this. Remember, I can simplify all of this. Here, let's duplicate the slide. And then we're going to call this one the simplified version of it. Simplified. And I promise we're going to go into code right after this. See it? See what I'm doing to simplify? X to the 1 is the same as x. X to the 0 is the same as 1. Right? X to the 0 is 1. That's what it looks like. Make sense?
Yeah.
Okay. So, if we could, let's change the way we normally do this. Let's make it A be the number we add at the end.
Okay.
Okay? Let's make B be the number we multiply times x, and C be the number we multiply times x squared. In other words, I want this.
Quadratic.
I want to do this. And that way, when we want to go to here, we just add one more. The other thing that
so much easier.
Does that make, yeah, that's what I'm talking about. The other thing that I want to do, the other piece that I want to do, and let me just put this up here because oh, this was Smash 8 Tapped who said this. Binomial means we have two dummy variables, x and y, and you're working with a monomial, just one variable. Okay, thanks Smash 8 Tapped. Appreciate that. Yeah, like I say, I'm an amateur at math. Here's what I want to do. If we want to change the value of b, if we want to make it go up, I want to just hit the letter B. And if we want to make it go down, I want to hold down the shift key and hit the letter B. Or maybe the other, switch those around. But do you know what I'm saying? If we want to change the number for the letter B, I want to hit the letter B. Does that make sense what I'm saying?
Yes.
And if I want to change it the other direction, I'm going to hold down the controller, the shift key. Maybe the shift key. So shift B will go down and B will go up. Does that make sense? Mm-hmm. If we hit A will go up. And if we hit shift A, what will happen?
If we hit shift A,
then I want A to go down. And if I hit the sheet,
oh right, because we're not using the up and down arrows.
Yeah, we won't use up and down. That's kind of what I'm playing with. Or we don't have to do that. Or we could do this, Campbell. We could hit a letter, and when we hit a letter, that's the one that's selected, and then use the up and down arrows to change it. That's probably easier. Do you want to try that instead? Sure. So you hit the letter C and then up and down arrows. Okay, back to your machine. All right. So what we need is we need some way to know what letter's selected. We need to change our B and our M to A, B, and C. Oh, hold on. Looks like there's a little extra key right there we don't need.
Oh,
so
oops.
First thing we should do probably is come up here and rename M to A, for example. Or actually, you know what? Maybe B. Well, never mind, because we already have a B. Yeah, it's already confusing because we're changing letters around. All right, B is going to be B. Wait, when you rename them, make sure you use the rename function that's built in. Let's, so undo all the way to the point where you had M and the X there. Because there are other reference to these, right?
Yeah.
Okay, it's not too bad because there are only a few and we could find them even if you didn't do rename on it. There you go. All right, so M, we're going to go, well, let's call it A. We can call it A. All right. And then let's add a C. Let's duplicate that line that you're on right there, 14, and add a C. So we've got A, B, and C. You duplicate line 14 for me. Is Campbell homeschooled? Is the question.
No.
Not homeschooled, but kind of. Well, he goes to school remotely, is what he does. The closest he gets to homeschooling is this show, I think. And if he wants, like, if he or his sister want a chocolate, I'm like, well, here's what you got to do. You got to jump through this math hoop. Okay, we got A, B, and C. Let's tab to next reference on the A up there, or scroll down either way. It's not too. This file's not too big right now. Okay, see what's going on here? Y equals. We're going to change this equation so it looks more like what's on my screen right here. See it? Y is equal. We want this one. Y is equal to C times X squared plus BX plus A. See it?
Yep.
Okay, so we're going to come over there. What you got? C times X. And you could do X times X if you wanted to. That you cannot do in code. To do the equivalent of that in code, it's something called, can I write it for you? Or you can just do times X if you want.
What is it?
Okay, I'll show you. It's something I've never liked. I always like this better. Just to be very clear, I like that. Or even better is to do that and then see it actually implemented in an X squared. It would be gorgeous. But instead, we have to do this. Math.pow for power, right? You might like it because it's kind of like a comic book. Pow, right? And we pass in X, which is the value we want to change, and the power as the second piece. Does that make sense, what I'm doing? Okay. The problem is we're getting it doesn't like it because this is, I think, returning a double, and we need a float, which I think we can fix by just typing, by doing this here. By the way, to fix that, let me show you how I got that quickly. I typed in C for cast and F for float. And what it does is it casts the result to a different type, changing that type. I apologize for throwing all this new stuff at you right now, Campbell. I know it's a lot, right? But it's C times math.
That's a lot.
It's a lot, isn't it? All right, you know what? You're forgiven for wanting to just say, you know what, Dad, I just want to do this. Okay? So we've got that. That's my squared. So I've got that. What goes times the X? You want to look at my screen again? Here's what I got. So this one is the one we're doing right here.
B.
Okay? So go ahead and do that.
And then
you want to times. Don't forget you need the times symbol in code. When you're writing code, bx could also be a variable somewhere that you might mean to reference. There you go. Good. Plus, and then what's the last thing we're adding? Do you remember? Do you want to look at my screen?
It's A, right?
Right. It's A. Okay, good. That is an important change. Good. I think that's all that changes here. Let's scroll down and see the next reference to A and B. I think that's just when we're modifying the letters. Here it is right here. So now what we need to do is we need to check to see if it's the letter A, B, or C.
I have an idea. We could create a Boolean, and then once we hit a certain letter,
yeah,
change that Boolean.
Let's create, instead of a Boolean, because
we've got an enum.
An enum. Let's create an enum. Let me show you how to do that. If you go up above this update right here, you can actually create an enum inside the class. So if you go to line 65, and you just hit enter there to get an empty line there, and you type in E space, you're going to get CodeRush's enum template will come up here. Now type in the name of it. We're going to call this
A, B, and C.
What are these things called in mathematic world? They're like the factors. What are they? The multipliers? What are these things called? Oh my gosh, I should know. We're going to go, I guess we'll call it the multiplier. Let's call it multiplier right now. I don't know what they're really called. Somebody out there in chat can maybe help us. Coefficients. Smash 8 Tap is there helping us out. Coefficients.
Coefficients.
Yeah, let me let me get that word here if you want to. And I'll copy it. So if I can copy that to clipboard, come over and paste it in here for you. So you don't have to type all that in. Coefficients. Make that with it right there. And then I want you to just hit the letter A and then hit enter. B, C, and you know what? Yeah, and you can. There's one other thing I think you can do here. So let's stop a second here. I want to just come over here, and I want to see if CodeRush's smart duplicate line works for you. Yeah, just hit Shift Enter a bunch of times right now.
Oh, okay.
CodeRush sees the pattern, and it's going to just make a bunch. So now we can make 26. Stop at C. We get to Z. So now we can model up to a degree of 26. Yeah, I said stop it. See,
I know.
All right, delete those two commas. Delete that comma there too. You don't really need that last comma. Okay, so those are my coefficients. Okay. Oh. Then what I want to come down here, and I want to do one other thing. I want to create a variable of type coefficient. So I'm going to just do this right here. We're going to call this selected coefficient. I think I've got this on the clipboard actually. Like that. There's my selected coefficient. For now, we're going to set that equal to A. Okay? Got it?
Yep.
Then we're going to come down here and say, hey, if the key is down A, then I'm going to say selected coefficient is equal to coefficients.A. Right? With me so far?
Yep.
I'm going to duplicate this. Switch this to B.
And then just Shift Enter, and it will work. CodeRush will do it.
And do that. With me so far?
Yep.
I'm just hitting Shift Enter all the way down, all the way to get to Z.
Yeah.
Right? It's a little crazy, but you know, that's what it is. Okay? I can also take all of these out of here, and I can do this.
Method?
Extract method, check selected coefficient.
Yeah, because if we ever review this code, that's going to be a lot.
Yeah. I still have this. This was the if thing right here. I really want to do this. I want to now have two more in here. I want this to be, if it's up arrow.
Wait, Dad, can I do something real quickly?
You bet.
Okay. You can do your thing.
Oh, I just want to make this up arrow right here. So if it's up, then what I want to do is I want to say, if shift key down, well, we don't need this anymore. This was determining which one it is. So now it's just going to be something like this. But now what I want to do is I want to say modify coefficient by get step. And I want to tell it which one. It's going to be the selected coefficient. Does that make sense?
Yep.
What I'm doing, I've got a method that doesn't exist yet.
Extract as method.
And then the other thing I'm going to do is down here. Notice we're subtracting here for the down arrow. I'm just going to come down here and do the same thing, but I'm going to give it a negative value. Does that make sense what I'm doing?
Yep.
Next, build this, right? So we're going to declare that method. And now watch this. I'm going to copy this to the clipboard. And I'm going to use a template called SW. I'll let you type it in. SW stands for switch. Holy cow, we're about to learn something new. Hit the space bar and watch what CodeRush builds for you. It's time for Code Jam. You know, throwing a lot at you.
That's so
something new.
cool.
We're learning something new. A switch statement. I'm going to try and simplify this as best I can. So I'm going to duplicate this right here. Switch statement. It's a new thing that you can do in code. Switch statements. The essence of a switch statement is, let me change the layout of the slide. The essence of a switch statement is it helps you make a decision, a one of many decision. A one of many decision. That's what it's for. Now, if we look at the code that's over on your screen that CodeRush generated for you, it basically gave you a whole bunch of pieces right in here, right? Switch of all of these different pieces, right? Does that make sense? So what we're going to do here is we're going to say A equals A plus value, like that, okay? And actually, you know what I'm going to do? I'm going to delete all these. Because you know what? I can help, CodeRush can build this for me just as quickly using duplicate selection. I'm going to select this, duplicate that, and it's already got the B for me. Just duplicate, and it's got the C. That's all we need for this one. But if we want to keep going, what are we going to hit, Campbell? Are you with me?
Shift enter.
Yeah, you're a little bit out of focus. You might move in close towards the camera and then back out again. There you go. And then get it to kind of follow you. Come on. Come on, camera. Figure out where Campbell is.
Better? No?
No. What's going on? Give it a look.
No.
What's going on?
Wait.
The camera does not want to focus on you. Let me, you know what? I got a remote focus control, I think, from over here on my machine. Let me see if I can trigger that.
Oh, that's a bit better.
Yeah. Oh, there it is. It just as I brought up the dialogue, it said, oh, okay, Mark, I'll do it. I'll figure you out. Okay, so we can hit Shift Enter to keep going in the code there on line 108 if you want to keep going all the way and build them all the way up. Yeah, Smash 8 Tap is pointing out a very important scientific principle, which is that the camera is out of focus because of all that math.
Yep.
That's what I thought. Shift Enter. Try hitting Shift Enter here. Is that going to work? You might want to be at the, yeah, you got to be at the end of the line to make that work. But if you select that case from the word case to break, and what's happening here? Let's talk about what's happening in the code here. Because are you numb at this point? Is your brain numb?
No.
Okay, because mine totally would be at this point. Case coefficient. Basically, what's happening is switch checks to see what the value is of coefficients coming in. If it's A, we execute this line of code. When we see the break, then we get out of the switch statement and we come down here.
Then
What'd you say?
if it's B, then it's...
Then we only execute this line of code. We see the break and we're like, okay, we're out, and we get out. So it's only going to do one of many. And I just want to come in here and let's just duplicate this all the way until we get to like all the way to Z. So we can just go crazy and say, you know what? We've got ourselves covered. All right? And there it is. Oops. Guess what? All of these don't compile because I don't have those letters yet. But you know what? I'm going to go ahead and add them now.
Oh, wait.
Why not?
Ready? Ay.
Why not? It's not hard to do.
No problem.
And now we've got this massive, amazing...
Imagine having to do this without CodeRush.
Yeah, it'd be hard. There's my sales guy right over there, Campbell, with CodeRush sales observations.
But
okay.
like no shift enter.
I almost feel like we're done. I almost feel like we've done it and we're ready to go. Let's just double check this. We want to. I'm looking for the. Where's our check for the up and down keys? That's what I'm looking for.
But we won't be able to.
It's in our update method. Here it is, right here. This is the core pieces right here. We select a coefficient, then we move it up and down. Smash 8 Tap says, I got to check out CodeRush. Smash 8 Tap, I'm giving away free copies today. So if you want a copy of it, if you're working in Visual Studio, it's an add-in for Visual Studio. We can get you a free copy right now. That's what we can do. Let me know, and I will DM you after the show. Whisper over to you on Twitch if you're working in Visual Studio. If you're not, that will not apply.
We have to change this, don't we?
We'll change what? Yes, we do have to change this. Wow, that'd be great. All right, cool. I've got it in there. I will reach out to you after the show. Look for that in the DM. Okay. Yes, we have to do that. We have to change this. And what we need to do here, this is a really great observation, Campbell. So this becomes A. This becomes B. And then we're going to add one more. Go ahead, what?
C.
Yeah.
Here, wait, can I?
Yeah, go ahead.
Can I do it?
Yeah, you bet. And this becomes C, and it's C times X squared.
Yes.
Now, there's a way you can get to the squared. No, not there. Because this references the variable. The F3 says only 3 decimal points that I want to see. We need the square right here. There's a program running here called char map, character map. So let me show you how I got it. I hit the Windows key, and I typed in char. See it right there?
Yeah,
Suggested. Hit enter on it. And now if we go in, we should be able, there it is right there. See that? That's your squared symbol. You got a squared and a third that we can get.
A cube.
So we can select, copy. Yeah, cubed, I mean. And you can come in here and paste it. See it? And so it'll still look good. So we'll at least be able to go to cubes.
That kind of reminds me of in Google Docs, there is an option for like every character, like a lot of characters.
Yes, there are a lot of characters. There are. But they don't have, I think, 4th and 5th. They might. No. They actually might, but they're somewhere else.
But in Google Docs, you can also go in, you can do an equation, and then it will automatically insert it for you. Yeah. If you do that.
All right. I think we can run. So we're starting out with, wait, is C0? Wait. What do we got over here? How come the Graphinator's not updated yet?
It's updating. It's a lot.
Oh, wow. Look at what we did. Maybe we shouldn't have done everything we just did.
A should be 0 as well, right?
Well, right now, if A is 1 and the rest are 0, that's actually okay. You can set them whatever initial values you want here.
Oh, because we're going to change
Even if you set it all to 0, that just means Y is 0.
Yeah.
For whatever X is, which means you've got a horizontal line. Okay? So there's our equation.
Why is it so big? Oh, right.
It's a horizontal line. So see the horizontal line? You can barely see it there, right there. So now you're moving A up and down.
Yes.
Right? So now if you hit the letter B, there you go. Now look, we've got a linear equation. Now you want it because the C is a 0. Right? Let's switch it. Oh, look at it, Campbell. He's already, look at that. Look at that. So that's 0.1, 0.2. Look, he's got negative numbers now. Is that cool or what?
Super cool.
And that's the show, kids. We're done. Are we done? I don't know if we are or not. But that's that.
You're done with the show?
We can be done with the show if you want to. But look at that. Look what we've got.
What?
we've got a polynomial grapher. And so Campbell, hold on a second. Let's switch back to Campbell's machine right there. That's Campbell's sister in there checking it out.
I'm Campbell's mother.
So we're graphing this equation up at the top that you see across there. And don't forget, you can hold the control key down to go up and down by 1.
Oh, yeah.
Right? To really tighten it up.
Polynomial graph.
Yes, it is. It's a
What?
polynomial graph.
Holy bananas.
Yeah.
That's
Isn't that-
amazing.
Isn't that cool?
Hi, Pudding.
Hey, Pudding. Smash 8 Tap is out there as well.
Smash 8 Tap. I don't know Smash 8 Tap.
No,
That's a fun name.
Smash 8 Tap is here.
That's a fun name to say.
Yeah, I like it.
Smash 8 Tap. All right. Cool.
That's it.
As interesting and compelling as this is, I'm going to go.
You gonna go? All right. You don't want to stand here the whole time?
I don't
All right.
stand here. Not even now. It's a little much.
Okay.
But I do like what you're doing with polynomials. I feel like I can so much more easily
Right.
visualize them now.
Yeah, it is better. Campbell, make it curvy like you are right there. The other thing, look at this, right? It kind of goes right to there. But if we could change that number by even smaller amounts or bigger amounts, right?
I'm just zoning out. Campbell's just lost in polynomial.
He totally looks like it. I was just thinking something else we could do. But actually, what are you thinking, Campbell, right now?
Trying to get it centered.
You trying to get it centered?
B.
So look at that. When you take the multiplier and change the multiplier on x, it kind of starts to move left or right, it looks like. Is that true? When you multiply when you change the multiplier on x, which is b, what happens when you change it? Get the curve back up.
Oh,
on it.
sorry.
Get the curve. Now, if you change the multiplier, what's happening?
Already? Wait, it's gonna
kind
go.
of like-
It's gonna go in a circle.
It's kind of diagonally moving, is what it looks like. It's like it's kind of changing the slope almost of kind of the diagonal component of it. Almost is if you can imagine a diagonal line. Isn't that funny what it's doing? How you're changing that? That's not something I've ever visualized before.
Yeah, me neither. And then with A, it moves up and down.
Right. That we know.
Yeah.
That we totally know. What's interesting about this, if you think of the bottom of that as like its own point, the very bottom of the curve, Campbell, when you move this, when you move change x, it's as if it's attached to the diagonal line and moving, it seems. Do you know what I mean? If you can envision that diagonal line.
What?
Yeah,
Wait.
it's hard to say, but I think what I want to do is this. To visualize this, I actually have to create a second line that only models the linear part of this. Can we do that, actually? Do you mind if I just do a couple things on your machine?
Yep.
All right.
No, I do not mind.
Okay, don't mind? All right, cool. So I want to do this. First, actually, I want to ask you to do something for me. I want you to create a second prototype that's red. A red sphere that we're going to drop down. So duplicate the point prototype, create a second one. Make this one red. So I have a theory that there's a connection, a relationship. And now we got a dog in here. Hold on a second. Okay. All right, what are we doing here? I looked away. You got the second prototype, making the material red. So this is something I almost feel like what we're about to do, Campbell, is something that very few people, if anyone, has ever visualized before. But what I'm going to do is we're going to simultaneously model the second degree equation and the first degree equation at the same time. Okay, that's what we're going to do. I want to create a new property in the script that's going to be we'll call it our linear point, I think is what we'll do. Our linear point prototype. Look for the one that we already have. See right there? Duplicate that line. Good. Call this the linear point prototype. And do me a favor, give that an uppercase
Yeah,
L.
I'm doing it.
Thanks, buddy. Perfect. Copy that to the clipboard. Go up to where we have point prototype and tab to next reference on that, on point prototype. Smash 8 tab. This is a coder's feature too, hitting the tab key to jump to different references. Look at this. Okay, cool. Here's what I'm just going to take over the keyboard for a second here. Here's
Okay.
what I'm going to do. I'm going to take these two pieces right here. No, these three. Those four. I'm going to extract these into a method. We'll call this add quadratic point. And then I'm going to duplicate this and call this add linear point.
Oh, so that we can do either.
Yeah, and I'm going to change the equation.
Yep.
So we get rid of this. Get rid of the squared. So now we just have a degree of 1.
And then in the one above, we add the...
No, this one I'm going to change this to linear. Right here. If that's where you thought I was going, that's where I'm going.
No, I was talking about the add quadratic point.
I don't need to make any changes here. I think this is still the same because we're already doing that. I then want to come in here and I want to duplicate this line and add the linear point. I think we're done. Try running it now and see what happens. The linear equation is in red. All right. Smash 8 Tap says, yeah, I'm just amazed you guys are swinging through the code so swiftly. Yeah. So, all right. So here we go. Let's start graphing. Do we have a problem? I'm not seeing any graph at all. Oh, we didn't assign that point. Let's do that. Oh, let's call it the linear point. Give it that name too. Good, good, good. Nice, I love it. Now let's run it and watch what happens when we change the B component of it, the multiplier for X. So there you see them both, they're kind of like on the same because as long as C is 0, they'll exactly overlap. But change C for a second and then I want you to change B and watch what happens to both lines.
Oh, okay.
Okay, now, good. No, go and make it so we got a curve. Now go and change B and see if there's a relationship between the positions of these. Look at what's kind of happening.
It's kind of like pushing it off, it looks like.
Yeah. Look at isn't that kind of crazy? The relationship? And now let's go change the A component at the far right. What we're going to add there. Hold the control key down and make it move by bigger numbers. Isn't that crazy? Notice they always... Look at where they always intersect.
It's that one line.
It's when X is 0. They always intersect when X is 0, because that makes sense, right? The only thing we'll have left is this piece over here. Also remember, even X to the 0 power is equal to 1. All right? Got it?
Yes.
You want to take this to the 3rd degree real quickly and see what that looks like?
Sure.
Shall we create a new point prototype so we can see all of them together?
And maybe make that one blue.
Okay, I love it.
My mouse just went onto your screen.
Okay.
For a sec, though.
All right, no worries. All right, let's make it blue. Let's get one more prototype in here. This is super cool. This is cool, Campbell. I think nobody's ever done what we're doing right now before. Nobody's seen the relationship between the different degrees of the polynomials as they're manipulated around. What is this type? This is... Oh, it's the material. Yeah. I gotcha. Okay.
It just looks different when you're naming it.
When you're typing it? Okay, yeah, I was like, what's going on with that? So this one's going to be for the cubic, which is going to be our D multiplier. D times X cubed.
Control D.
So we'll call this a cubic point prototype. That's in blue.
Cubic.
Okay. I love it. I love it. I love it. Now we need to add a property to the script. I love it. I love that you're moving it so we can see all of them.
Ah. Okay.
All right. We're about to discover for the first time what these relationships look like. connected to each other. All right, so we need to, yep, your intuition is correct. Let's start with the quadratic point and duplicate that.
Oh, yeah.
That one right there. Do that because that's going to be the easiest to change right there. We're going to change it, call it add cubic point. Don't forget you've got alt, left, and right arrows plus the shift key to select just that middle piece right there that you want to change. Alt, shift.
Oh, sorry. Alt, shift.
Yeah.
Boom.
There you go. Good. Cubic. All right.
Big point.
And what do you think the change is down here?
Oh, we do
inside.
D.
Yeah, don't. Yeah, go ahead. You're right.
Times D times.
It's not times D. Look at the pattern.
Sorry, times X.
Yes.
Times X times X.
Yeah. And what operator is between that X and the letter C?
Plus.
Yeah.
A addition.
Exactly. Good. We've got that, but nobody's calling. Go ahead. Go ahead. Wait, we're doing derivatives now? It's asking. I don't know what derivatives are. I haven't looked up that word yet. This also shows how any curve resembles a line or lower degree polynomial locally. Wow, okay. Cool. I think Smash 8 Tap just totally blew my mind. I'm like, wait, what? It resembles it. I guess it to any curve or lower degree polynomial. I guess resembles it. I don't know what that word means really, or what we're talking about with regards to resemble. Let's see. Where are we? What do we do? What changes did you make? We still, I think, need to call the, add cubic point. There's another thing that needs to change on line 82. There it is.
And then we also have to change it on the line above.
No, quadratic point is still going to work. That's still
Oh,
using
sorry,
the
wait,
original
on
one.
this one. Oh, we already did.
You saw x is equal to 0. The triggers, yeah, we're very close. If that's what you mean by resembles Smash 8 Tap, yes, I totally agree with that. Yeah, they resemble each other at that point. Yes, I gotcha. I totally agree with that, Smash 8 Tap. Great observation. Oh, look at you, Campbell. You figured out the missing piece. Beautiful. I think you're done. Save it and run. And we're gonna now check out the relationship between two of those. Remember, so the highest one is blue. The second highest degree. Oh, shoot, we forgot to change this.
Every time.
That's all right. We're going to get it. We'll get it. Oh, yeah, we forgot to do that. And we forgot to change the text.
Oh, right.
Get the cubic. There you go. The text we need to modify. I forgot about that. There. So, yeah, copy all of that. And then put it at the beginning. Remember how I did it?
Yep.
There it is. Good job. There's your 3. You can select it and then copy it. Hit the copy button right next to it, or hit the copy key. There's a copy button right next to the select button too. Next time you can get that real quickly. All right, good. Good. And what else goes between those two? Oh yeah, good. And what else goes between that x cubed and the what operator goes here? Perfect. Save, run. I think we're done. We're making some progress on this show, I think, today.
Yeah.
Right, we're getting through stuff pretty quickly. All right. So whoa! All right, so let's play with it. Go ahead and let's play with it. Let's give me something. Give me a value for C here as well.
For C?
Yeah, because I got 0 on there. There you go. Now let's modify B. Look at this.
It's modifying all of them.
Isn't this cool?
So cool.
Yeah. There's a theorem in math that says you can write a high degree polynomial in terms of a lower degree polynomial with the help of derivatives, which is what you guys are playing with. Oh my God, we're playing with some sort of advanced thing, Campbell. We're geniuses. We became geniuses today. Says, where's my party button? Where's that button? There it is. We did it. Nice. Well, we just did Taylor's theorem. Let's go back over to your machine. Let's see what this is looking like. Oh my gosh, I love this. Is that awesome or what?
It's so cool.
All right, you want to go.
The closest they get to like aligned is there.
When you get right in there and you look just at it. Yeah. So this is what he's talking about. This is what Smash 8 Tap is talking about. He's talking about how it resembles the line. See, as you get right in there, as you get close to X, right?
They all start to look the same.
Yeah, when X approaches 0, they start to really look the same when they at that crossing point. Yes, those are approximations. Pudding says, no, this deserves party 3, is what Pudding says. All right, we'll do party 3. We normally don't do party 3 on the KidzCode show because people don't quite understand what's happening. But right. There's Newton's polynomial, Taylor's polynomial, and others. Really? I didn't know that at all. This is all new information to me. You want to add one more?
Yeah.
Can we do one other thing? Can we change the number of decimal points, drop it down to just 1? So we have more space up here. Look at all those zeros. See what I'm talking about? Is that okay with you, Campbell?
Yep.
Okay, so that means all those F3s become F1. Good. And now we got to figure out if there's a fourth. Let me go see if I can find if there's a fourth in the char map out here. I think there is. I just got to scroll way down.
There should be a search option.
Yeah, there should. There's not a great search option in this. I found it. It's about 2/3 of the way down. I'm sorry. It's like down in this space right here. There it is, right there. See that guy?
Yep.
There's your fourth.
Select
Whoops.
it.
You go ahead and get it. Take
And
your
there's
fourth.
also a fifth.
Take your fourth. Let's just do fourth. Select copy. We need to add a new prototype. Give it a color like purple. Something like that.
While we're still here, I'm just going to. There's not a good way to do this.
Tell me what you need to do.
I need to take this, put it here without
Right.
copying it.
Yeah.
Because I still want to keep.
Here's what I think you can do. Try this. Select that expression, shift enter on it, like that, and you're going to have to change this. You're not going to change this one. You're going to just go back and change this one.
Yeah.
Does that make sense?
See?
E goes there, and
No.
you're going to have to paste in the 4 there. So yeah, because there you go, like that. Discussion happened out here in the chat room. Next on this show, the Fourier series. The only sad part about the Fourier series is that we need to understand integrals. And Smash 8 Tap says, in a few months maybe it's possible. I see Campbell has a really steep learning curve. I'm going to take that as a compliment that he sees you're going pretty quickly on this. Pudding says, or Smash 8 Tap says, and trigonometry as well.
Yeah.
Pudding says he knows trigonometry already. Not really. You've got Pythagorean's theorem,
Yes.
is what you got. But not really trig. Anyway, Pudding says, not perfectly, but I'm pretty sure he understands what sine and cosine are. I don't think you know those yet either.
No, not yet.
We have not talked about those yet. So those are kind of for later. So now, I don't even know what this next one is.
Add
fourth
other?
point or power 4 point, maybe? Power 4 point? I don't know what this last one is.
I'm going to go with add other point.
At other point, that's fine. So do this again. Select this through all those X's and the plus.
Oh,
so
wait,
just
I
Control Shift right arrow. Control Shift right arrow kind of goes from word to word. You might have to hit that a couple times. But that'll get you there. Now hit, there. Get to just before the B. Now duplicate the line. Duplicate that selection. But now instead of changing this, you're going to go back to change. Wait, we want that B to be a C. And we want the C on the far left to be a D. And multiply by another times X. Does that make sense what I'm saying?
Yeah.
Another times X there. You can select that and duplicate that as well if you want. Or just times X it. Good. Okay, so we've changed that. Is there line 83? I think we need to change line 83 as well.
Wait, we're not done. We have to do E.
No, I think D is the new one, isn't it?
No, we already did E. D.
Oh, that's in cubic point. Oh, I see. You duplicated quadratic point. I'm sorry.
Yes,
Okay, I got to
sorry.
it. No worries. That's no worries. No, I'm glad you're on top of it. I'm like, do-de-do-de-do. I'm like, what's going on? That's me. And so around now you start thinking, oh, okay, now I see the power of the math.pow call. Because now I can, do you see what I'm saying? Now it's like I don't have to start counting, right? So I start getting into x times x times x times x. See what I'm talking about? We'll probably stop here.
Yeah.
Yeah, Smash 8 Tab is saying, hey, I think it would be very cool. It would be great if schools start teaching how Mark is teaching. You learn code and math at the same time. Very cool. I agree. I agree, Smash 8 Tab. I have one of the things I'm sad about in terms of the way most math is taught and physics as well is they teach it. They basically say at this moment in time, let's study what's happening at this slice in time, at this instant. But they're never like what's happening the whole way, right? What is the whole thing happening? And so I really like the ability to visualize, you know, in two-dimensional space the whole thing, right? Not just where is the point on the line, but what's actually happening as we're making changes. Okay, so we've got the other point prototype is what we're calling this guy. Good. All right. I haven't been following you. I'm just talking to Smash 8 Tap right now, Campbell. I don't know what you're doing. Sounds like you've modified the text string. Have we hooked up the script piece? No, other point pipe, other point. Yeah, that all looks good.
Let me go.
Right here, other point prototype in the script, the main script.
1 sec.
Oh, we didn't create it yet. Gotcha. Okay. Other point prototype. This is exciting. We're about to see something nobody's seen before on this planet. You guys are here with us. In physics, they just give you a math equation and say take a math class to understand it well.
Yeah.
That might happen a little bit.
I'm going to make this one green.
Okay. That works for me. Green and red are hard to differentiate between each other if you have color blindness, and about 1 in 10 men have it. So I would, if you do a green, make it a green that's a different shade of the red, like a different brightness.
Yeah, I'm gonna do like
a bright green, maybe.
like a shamrock green.
Okay, yeah, make it a really bright green, so that in case anybody out there is colorblind, they still are able to see it. Pudding says Campbell's building Skynet while you're talking to us. That's funny. Skynet is a fictitious program that takes over the world in a movie series called Terminator, Campbell. It's about robots from the future that come back and try to destroy humans.
Yeah, I've heard about it.
Yeah.
But
all right, cool. So we've got a bright green in there.
it's not on it yet, but it will be.
Okay.
Soon. Now.
All right.
Like that? Is that good?
Yeah, I think it's okay. It's a little bit the same shade. If we could get it like either much brighter or, you know, maybe change its reflectivity or something. Yeah. Let's move it closer over to white if we can, if you don't mind. Just half the distance between where it is and white. If you take the, let me show you what I mean. Yeah, take that, drag that over to the right. Can you drag it? Yeah, do that. Close it down. Yeah, now it's too close to gray.
It is.
All right, so that's not working. Can we make it purple?
Yeah.
Because then purple is like right between, and now you can make it deep purple. Those will be easy to differentiate. Okay. Smash 8 Tap says, gotta go. See you guys later. It's great hanging out with you guys. Smash 8 Tap, in about 30 minutes, I think we're over. We're done with the show in about 30. So check in about 45 minutes. All right, so let's go. We haven't yet explored the fourth, so you gotta give me a D. Something for the D there. Right over there.
Oh. I thought I pressed D. Yeah, I did. Wait.
You're hitting D and it's not changing D?
Oh, I'm supposed to hit E. But
Oh, it's E. I'm sorry. You're right.
no, that was me.
No, it was me because I said D. So hit E.
I also thought it was D.
So hit E and let's see what's going on with E.
E. Huh?
Oh wait, keep going though. Look at it. It's a little bit different.
It's more like square
Yeah.
and then curved up.
It is. It is. It totally is.
I'm gonna give D something. Whoa.
Yeah, see how the higher level one is purple, right? It's the highest degree polynomial.
Oops,
That's the
not
4th
B.
degree. Yeah, no, go ahead. Give a value for each one of these and let's see how they resemble each other. And one more for the
B.
B. Perfect. There you go. And now look at the higher level ones. Look at the curve that it does.
What about A? Okay.
I want to make it so if you hold the key down,
You can move it as well.
yeah, it moves multiple times. I'm not sure how to do that in Unity in a way that doesn't make it get out of control.
Yeah, because if you do it, if you do it in Unity, if you just tap it once, it will count it as multiple times. If you have it like that.
Yeah, so there's like no precision there. It's kind of cool. I also don't like here how the pieces get far apart. We could fix that by changing the step if we wanted to.
Yeah, like right here, the pieces are sewed together. It looks like just a straight line.
Yeah.
For at least the red one.
There's another thing that's happening too. Our smallest number that we can set it to is 0.1, but I would like to see what happens when it's 0.01. Let me show you what I want to do. I'm going to come over to your machine for a second. I'm going to come into, where's our UI? Right here. I'm going to come over here and I'm going to say UI, add some text. This text, I'm going to call this the incrementer.
Sure.
Is what I'm going to call this. And the value for it is going to be 1. And can you get this, Campbell, so it shows, I want this in the upper left of the screen. So I'm going to do that. I want to say, what's our, we're going to overflow and we're going to overflow.
And then also, wait, we have to do one more thing.
Get it so we can see that thing on screen, please. I want to see that in the upper left is what I'm looking for. Oh, it's position X and Y are too big, I think, right up there.
Right.
Don't forget, yeah, there you go. Get that in the upper left. Yeah, just drag that to the,
Oh, I see it moving.
yeah.
Now we just gotta make the Y higher as well.
There we go. Move that further to the left if you can. There we go, there we go, there we go. Go, cool, cool. Make it white.
Yep. Color.
So this is what, I want this to tell us how much we're going to go up or down by. In fact, let's do this. Let's come in here. I'm going to duplicate this. How do I duplicate that? Or you duplicate. Give me a duplication on incrementer and put this next thing right down underneath it. All right. For its text, changed it to selected coefficient. Yeah, put it down there. Perfect. In the text, call it selected coefficient and add a colon to it.
Here?
No. Yeah, there too. But this is not going to have a space in it or a colon. This is just the name of it. Selected. So now when you hit A, B, or C, it'll tell you which one you've got. Does that make sense? Coefficient.
Yeah.
Copy this so you don't have to type this in again. And then in the text, paste it down and then put a colon and hit the letter A. So it just says that A is selected. Colon, put a colon in there. Yeah. And put the letter A. And then go back and select the one above that says incrementer.
Wait, what do you mean?
Select it in the hierarchy. I'm sorry. And then instead of saying 1, say have the word incrementer, colon 1. So we're just showing you what we've got, what we're not there. I mean, down in the text.
I know, I'm copying.
Oh, okay, perfect. I'm sorry. I should have figured that out. Good. Now I want to add properties in the script to drag these texts over to there so we can modify them from the script. Can you give me 2 properties for these texts?
Yep.
We've already got one in there for the equation.
So I'm just going to shift enter it, yeah.
Where's the equation? There it is on line 45. So this one's going to be incrementer text. I think it's in the clipboard still. Beautiful. And duplicate it one more time. And then this one's going to be the selected coefficient text. This might be on the clipboard history. Try hitting, oh yeah, there you go. You can go get it too, but there's a way you can get into the clipboard history. But go ahead and do this. Yeah. I tend to avoid bringing up clipboard history when I'm live streaming in case I've had any sensitive information on the clipboard, like a password or something like that.
I don't think I have, but...
And let's change it to so the word text is at the end,
yeah.
so it's similar with the others. Excuse me. Control right arrow gets you to the end of that real fast. That's word left or right. Control arrow keys get you left and right. Okay, good. Let's go see where tab to next reference on equation text. Let's just see where we're using that.
Oops.
I think only there. Hit tab key again.
Yeah.
Cool. All right. Can I grab the mouse a second?
Controls.
That might have been my fault. I moved, I think, the mouse onto your machine maybe.
Wait.
What's up? Just hit undo. All right, cool. Let me come up here. Here's what I want to do. I want to take incrementer text and I want to change it. I want to do incrementer. We need to create a variable called incrementer up here. So I'll come in here. I'm going to duplicate this, call it incrementer. You with me?
Yep.
Call it 1. I'm going to give it a value of 1. All right, cool. Next, I'm going to create keystrokes for changing our incrementer. Where's my update? Here it is. Okay. GetStep has got this code, Campbell, that kind of worked for a while. It's not working so well now, which is basically, hey, if the control key is down, let's change our incrementer. I don't care about this anymore. Now I'm just going to simply say return the incrementer. Okay? That's what GetStep's now going to do. I'm not going to ask for the control key anymore. Okay?
Yeah.
But I am going to do this. I'm going to say, hey, if control key is down, then I'm going to say I'm going to modify the incrementer. And I'm going to say incrementer. So I'm hitting control up arrow. I'm going to say incrementer equals incrementer times 10. That's if we're going up. If control key is not down, I'm going to go ahead and do this right there. Now, if I modify the incrementer, I also want to modify the text that's out there. So I want to go and grab incrementer text and set it equal to whatever this is. Well, actually, I want to have the word. Remember interpolated strings?
Yep.
I want to have the word incrementer followed by the value of the incrementer. You with me on that?
Yes.
Okay. That's what I want to do if the up arrow is pressed. We're going to increment incrementer by 10. Okay? Now, if down arrow is pressed, I want to do this. I want to divide by 10. Okay? And then I want to say what the value is. Okay? Also, check selected coefficient. Here's our selected coefficient. What I want to do here is I want to say selected coefficient text dot text is equal to, I want an interpolated string again. And we're going to say, we're going to spell out the words selected coefficient, a colon, and then I'm going to pass in the selected coefficient. I think that's going to say the letter, whatever the letter is. If not, we might have to change that or figure it out, how to get the letter. But I think that'll work like that.
I think there's a problem.
Yes, what is it?
Not down here, but... Oh, never mind.
Let's see what it works. Let's see if it works. Let's run it and see what happens.
Okay.
What I think is going to happen is I think for selected coefficient, it's just going to, instead of saying A, B, C, or D, it's going to say 0, 1, 2, 3. And I think we're going to have to go change it up to get the letter of it. And I forget how to do that in C#. So we'll take a look at that. Oh, no, it's working.
No, it's not.
Yeah, selected coefficient is A. Well, how do we get back to MX plus B, though? Oh, I think I know why. That's how the starting text, we forgot to, in our script, we forgot to hook up the text. Bless you. Okay. Try running it now. Save and run.
Wait, 1 sec. Headphones. Yay! Ugh.
Got some overlap. We can
Lots.
drop the size of the font. But are you seeing now the feedback? Yeah, we're dropping the size of the font. Is that what we're going to do? Cool. That works.
Actually, no, I like the size of those.
Okay. We can also make that, I bet, semi-transparent.
Yes!
Does it work? So you hit the letter D, your incrementer. Now modify and see what happens over here to the equation. Oh, you know what we can do? We can give it a floating thing so it's rounding. Because it's not, this is the math error kind of thing that happens. It's off by a little bit as you're modifying it. It's a colon F and then the number of decimal places you want to give it.
And that's here?
Yeah. It's to the right of this, I think, as I recall. Colon, and then like F4 or 5 or something like that. Like 5 digits we can support, or 6 digits, whatever you want to support. Okay, good.
Maybe 4. I'm going to do 4.
Okay. It's totally up to you. I think we might find later that we're like, oh, we really want to explore more. Save, save, save.
Oh, sorry.
Okay, so purple is the highest level.
Yes.
That's degree 4. All right, I'm going to get rid of the words Campbell's machine on what we're sending out here so people can just see that way out there. Okay, there's your incrementer. Okay, now you're getting, okay, cool. Here's what I want you to do. Go to D. Yeah, you're on D now, right?
Yes.
Why aren't we seeing anything at all? Increment it. Oh, there we go.
I had the control key down for it.
The control key down.
Oh, I just realized something, Dad.
Oh, we're not redrawing it, I think. Oh, yeah. You're changing the incrementer, but you're not actually changing the value of it. I see what's going on. Okay, the reason these are still 0 up here, I think, hit your up and down arrow keys now.
Now we can't increment by 1.
I think we can. We just hit the control key down 2 times.
Because that modifies.
One more. One more.
Wait, what do you mean?
Control up arrow. No, control up arrow. Control up arrow is making it go smaller. That's where, there. No, now you're at 100. There's 10. Go down. Control down should take you to 1.
Oh, right.
For the incrementer. But you're still on 10. There. Now you're at 1. And you're modifying D, and then now you can modify E. Now we're not seeing it here because we only have this many decimal points. We're only showing 2 decimal points. Ah, look at that. That's what I'm talking about. I thought we could get some more interesting lines. Look at this. Right? As we're modifying. You can't see them. They're all zeros. We need more decimal points up here. Can we get to add more decimal points there to the equation? Maybe drop the font size down over here. What are you thinking, Campbell?
This is with an incrementer of 0.001.
Yes. You may need it smaller than that. I think we're going to need to go 5 decimal points to see more interesting things.
We can still make it go down.
Yeah,
Look,
it's just you're not seeing it because we're...
Now I'm pressing the up. Oh wait, it's just 0.
I don't think it's 0. I think... Let me just do a couple things here on this to see if we can visualize this better. I want to come in here. Whoops, not there. I've got the incrementer already selected. And I want to drop the font size down. So we see a little more on screen. Select the coefficient, drop the font size down. Okay? Then I want to go to the code, and I want to find that place where we're showing the equation. And switch this up. Let's give it back to 3 again. Because the problem is you're making changes, but we're not seeing evidence that we're actually changing anything, and I want to see the evidence. I think those are the 2 changes I wanted to make. Can you run it again? All right, now change your coefficient to, make it small, change your coefficient to E, and now modify it. And D, there's your D coefficient. And now just start playing. Change A, B, C, and D. And at these small values, and look at what's happening. Look at how wide it's getting. Is kind of what I'm getting at with this. I love it. Isn't this cool?
Yeah.
And you get our linear one in there. You need a mx plus b. Right there. There's our linear in red. I love it. Yeah, look what happens when you take that. Yeah, change your incrementer, drop it down. Yeah, good. Now you're seeing what's happening. See what I'm talking about? That's what I'm talking about, right? You're being able to have a finer control. Drop your incrementer even further down if you want. Take it from 0.1 to 0.01. Yeah, there you go. Now modify it. Look at how smooth that is now. You're starting to see what's happening in the relationship, right? Imagine if we hooked this up to a joystick where you could just do it and you could kind of see the bends of what's happening, right? That blue one, what is that? That's the cubic, right?
Yes.
That's the negative 0.2. Let's change the cubic. That's A, B, C, D, right? Let's change D and watch what happens to the blue line and everybody else.
It only affects the one greater than it.
Oh, yeah. So
if we were to
that makes
change
sense.
C, it wouldn't change B.
Yeah, that makes a lot of sense. Look at that. Oh, I love it. Look at how they're starting to resemble each other right there, too.
Yeah. If we get, the closer we get to infinity, the closer they get to the same.
Let's try that. Change our incrementer to like 100. And do we just get this straight line? You don't have to make it that big. Yeah, we're getting a straight line. Is what it looks like to me.
Pretty
Change
close.
it. Don't make it. You've got your incrementer at like what, a million? Change it to 100. Come on, young man. Be reasonable. All right, try that. Yeah, look at it. See it? It's going. It's just like this line that comes down and line that comes back up almost.
It's so close to straight
Isn't that crazy?
that our human eyes
I think we got a
perceive
show.
it as straight.
I think that's pretty cool. Anything else you want to talk about?
No.
Anything else you want to try?
Want to go higher?
If you want to, we can do it. I think there's something also, I'm not sure, but I think there's something about the odd ones. Notice we're at a 4. The 4 and the squared give us bowls. Remember the third gave us an S? What happens if we go to the 5th? Will we get an S as well? Like an interesting shaped S?
I think we'll get a boom, 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 like a mustard, like a bunch of S's.
Well, let's see what happens. Well, the cool
Maybe.
thing is we can check it right now. Let's get our 5th. So instead of saying, let's take our, can we take our other prototype and change it to like, you know, level 4 or something, degree 4? Call it degree 4 prototype.
Wait.
I'll do it.
Oh, the other one.
Yeah, I didn't like the word other because now we got a problem here.
Yeah. 'cause
So
we
let's do
wanna
this.
go
I'm going to rename this right here. And I'll say add degree 4. Whoops, I took the wrong thing out here. Add degree 4 point. Okay. That's cool. And in degree 4 point, we've got the other point prototype. I want to rename this to our degree 4. Oops. Degree, oh my goodness, 4 point prototype. Oops. And now I'm going to duplicate this, change this to a 5. We're going to come in here. I'm going to go from here to here. Copy
We should do
it.
the math, pal.
What'd you say?
Maybe not.
Tell me what I didn't hear what you said.
I said we should do the math, pal thing.
Oh, you want to do that? We can do that if you want. For now, just because we're doing this quickly, I'm just going to like do this now. We can clean that up later. Degree 5 prototype. The other cool thing about giving these numbers, Campbell, is that it now duplicate line is able to detect the pattern. And so if we had to do it again, see what's going on. Right there, it's much easier.
It makes it much easier.
Okay, so we've got degree 5 prototype. And we need to modify, we need this. Call here, wherever we're calling this. So we're going to say add degree 5 point.
And now it will do the same thing as well.
You need to come in here, modify this. And change this 4, char map, to a 5. And as I recall, it was down about here.
Oh, I think we just found it and passed it. No, it's further down than that. I think it's right about like
I think it's
here.
right about here. There it is right there. 5, copy, and paste it there.
And then F.
Oh, right. Thank you. Good job. I missed that. Save it. I think we're done.
We have
we need to do the
make
prototype and connect it to the script.
Also has to get renamed.
So this one, let's make this one be bright green. Because we're kind of running out of colors. Oh, good job
Or we could
there.
make this maybe a hot pink.
Oh, I love it. That's a great idea.
So this one is the degree 4.
Yes. Good job, Campbell. I love how you a lot of times I forget something and you're like, I gotcha. Right? You're like aware of what we're doing, what we need to do. I really appreciate that. All right, so yeah, my theory is it's going to look like the degree 3. The degree 5 is going to look like the degree 3. It's my theory, but I don't know. But I think it's also going to have like an interesting kind of flattening that we saw in the
purple one.
Yeah, but I could be completely wrong. Great. I love it.
Oops. No, too close to the other one.
You can make it black, or you could make it. Yeah, there. That might help. Try that. Move it a little bit away from it.
Yeah, so that we can see.
And you might. I think it's okay.
Yeah, I think that's good.
Okay, so now we need to go to our script.
Oh, right.
And I think we lost our degree 4 because we renamed some stuff.
We did.
All right. What a great show. Okay, take a look at that equation.
Oh,
All right, so to see the 5.
it does. Look.
Okay, now modify the 3. What is that? A, B, C, D. Modify the D and
sorry.
modify
F.
both. But I want to see that. Now I want to bring up the third and see how the third looks compared to it.
D?
Yeah, I think it's D. Yeah, see, now let's play with both F and D and just see how those... I want to keep the others out of the way is what I want to do, and we can do that just by setting those to 0. Let's compare only these two. So only change the coefficient D and... Let's see, D, F... Is it G? What is it? Wait.
F.
It's F?
Oops.
No, wait. A, B, C, D, E, and F. D and F are the two I want to change. Yeah, change those two and see how they connect with each other. See what happens.
Oh, wait. Oops.
Oh, wow. Wow. I didn't actually expect that. It flipped.
No, that was because of me.
Yeah, but yeah, there. I've never seen that before. I was not expecting that. That's kind of interesting.
This is negative and the other one's positive.
Oh. Yeah, I bet that's it. So the negative on one has no impact on the other, really. It doesn't seem to have an impact on it. So take that D, change your incrementer to, bring it back to -1. Oh yeah, look at what, okay. Change your incrementer to 1/10.
Ah, sorry.
So you got a smaller incrementer. Now try changing D. Oh, whoa. Oh, because we crossed negative. See what we did? We went from negative to a positive. Okay.
Oh, are they getting closer to being back to normal?
No, I think you see what's happening? The line's just it's kind of like twisting around.
Yeah, it's like wrapping itself.
Yeah, and the pieces are kind of getting together. That's kind of cool. It's kind of cool, Campbell. All right, I'm going to say that was awesome.
Yeah, I feel like what we should do is add like this, have this show that it's F, this show that it's E, this show that it's D, this show that it's C, this show that it's B, and then this show that it's A.
Okay.
I think we can actually make that change right now. Pretty easily.
Sure. You'll do it. Anything you do here is going to be outside of these braces, yeah. So be like...
E. Like that?
Oh,
yeah,
wait,
no.
Not.
This is F, sorry.
Yeah. That one's F. And I think the way I would do this, I'm not sure. I think I would do this. Here's how I do it. It's a little bit lengthy. Wait, give me a second here. But I would suggest maybe saying F equals this, like that. See what I'm suggesting there? And then this one's going to be E equals that. Does that make sense? See what I'm suggesting? And then we've got D equals. Yeah, I think you're right. It's a good suggestion to kind of orient it. Somehow we need some kind of indicator.
Before we were like, so A, C, B, B.
Nope, you're absolutely right.
Figure out which one it was.
No, you're absolutely right, man. It's a really important change. A equals that one right there. Okay. Want to run it?
Oops. Oh, I thought I forgot to save.
I think I might have saved it. I generally save about frequently, and there are a lot.
Yeah, much better. Oh.
Okay, we just got to drop the font size. Let's drop the font size.
By a lot.
Cut it in half. We could also take the incrementer selected coefficients and move them down to the bottom left. Yeah, 10. And let's run it. That's fine. We run it with that. Okay, better. Better. Yeah, I think you're right. It's a good suggestion. Play with that. See what you think.
look at this one cluster where they're all intersecting.
Yeah, it's really cool. Yeah. That's very cool. So now when you see y equals mx plus b, right? Whoa, look at that. That's so cool. It's like this spiral thing kind of spinning out. And also, like if you want to zoom in and see the motion, just drop your incrementer down, right? And then as you're modifying it. Yeah. It's cool. Okay. Let me show you one more change I want to make, a small change. I'm going to bring the mouse over to your machine. You cool if I stop you and get back to the code? Let's get over here, and instead of doing this right here, I'm going to do 0.00000 like that. So say I want to go, it basically says here, I want to show up to this many zeros, but you know what, if I got a bunch of zeros, if I got a whole bunch of zeros to the right, don't show them. I think that's what should happen here. So what as a result, if it's just a simple zero, we should just see that. Let's try running that and see how that changes the equation. Ah! What? That's not what I wanted at all. Oh, I know what I did wrong. My bad. Sorry. This should have been pound signs right here. 1, 2, 3, 4, 5. That's what I want. All right, now let's try it. Give me a run.
Yay, it worked.
Better. I like it.
Okay.
Make some changes. Run it and make some changes. I'll set up a raid, okay?
Okay.
Thanks, everybody, for watching. We appreciate it. Next week, I think what we're going to do is estimate the volume of a sphere. That's what I think we're going to do, using Unity. Give me some curves, man. Change some things, man. I want to see a bunch of stuff as we get out of here.
You messed something up. Or I messed something up.
Thanks for joining us. Smash 8 tap. We're going to get you copy code right here in a second. Look at that equation, man. You look like a genius with all those exponents up on screen up there, Camel. You notice that? Pudding says, thanks for the stream. You're welcome. Say hi to Lana Lux. We're going to send you over to Lana Lux. She's a game programmer. Does some 3D modeling. We'll see you next week on KidzCode.
Yep.